But it's not that fundamentals are not important. In fact, any domain in which you want to apply AI or AI, first of all, you have to have an expertise in that domain. It's not a black box that you can take and sort of plug in and it works for you. You have to understand the domain in which you are applying AI. So in this particular talk, so that's the term that I want to explain. And as we go along, I'll try to give you a flavor or try to convince you that we have already entered a new paradigm of doing research where a lot of things are driven by data that we have accumulated over the decades, over the centuries perhaps, and we are still accumulating. And again, before I go into the sort of central part of the talk, this is a recent article that I wrote, which was published in the Proceedings of the Indian National Science Academy. It's both a technical overview for undergraduate students. The technical part may be very heavy, but towards the end there is a section about the future, where all these are going, and I'm sure you will enjoy reading that. It actually will give you some of sort of greater exposition to some of the things that I'm going to talk about right now. Okay, so you know that materials are important in human civilization. In fact, so much so that we have named various historical epochs by the most important, technologically important. Ah, better? Is it better now? Yes. Okay. So much so that the various historical ages, epochs have been named after the technologically most important materials. So we have the Stone Age, the Bronze Age, the Iron Age, and so on. And the present age may be called the age of silicon. And newer technologies, future technologies will depend on the materials we design. Given the technology, we need materials with specific properties. If we do not have such materials right now, we have to design them, we have to find them out, and how quickly we can do that determines the pace of our technological progress. And the traditional mode of doing that has been the trial and error experimentation route. So what you do is, from your intuition, knowledge of basic sciences, you think about some materials which could be useful, then they have to be made, they have to be synthesized, they have to be characterized, they have to be tested. It's a long process, and in fact, to give you an idea about how long typically these processes takes, this cell phone that we all use, they all use lithium-ion batteries,
Yes,
which
sir.
is now a very common thing. But if you look at the history, the first time lithium-ion batteries were tested in the lab was sometime around
1970s.
this was yeah. So it took about 20 years for lithium-ion batteries to go from lab stage to commercial deployment, and there are still things to improve in that. So this is the time scale, decades, that you need from lab scale testing to large scale technological commercial applications. And precisely to shorten this time scale, a program was launched by various agencies of the US government in 2011, which is called the Materials Genome Initiative. And this has played a really transformative role in the way we do research in materials and the way we think about material science. Oh, I have to go here. So, what is the difficulty? Yes, I know materials have a certain type with certain properties for a certain type of technology, but what is the difficulty? The difficulty